All right, so now we're going to look at another type of transformation in geometry, which is a reflection. And a reflection is basically a transformation which flips the figure over a certain line of some sort. And that line is called either the line of reflection or sometimes the axis of reflection. Okay, so what we're going to do is kind of look at an image and then try to see how it's reflected. So as you see this image, ABC, that triangle, so this triangle ABC, and they want to reflect it over this axis here, so the x-axis. So the way you reflect that is you just basically think of it as a mirror that would flip something to the other side. So this B here, because it's exactly on the axis, is going to stay the same. But A is 3 away on this side. So now I need to draw A prime 3 away on this side. So it's on the other side. It's like it flips it over that line. So you can see A prime is now on the other side 3 away. And then I look at C prime, and if I went down to here, if I flip it over the x-axis, I'm going to go up 2. So here is C prime. Okay? And so I'm just going to quickly use this as my ruler, because again, I managed to forget to grab a ruler. And then here is my image. Oh, thanks. And I'll use an actual ruler, which is a lot easier to make that image. Okay, so there is my new image. The new coordinates, A prime got flipped over, so it was at the original A was at 1, -3. And you'll notice, now that A prime is at 1, +3. Okay, B was at 3, 0. And B prime is still at 3, 0. And then you'll notice that C was at 4, -2. And now C prime is at 4, +2. Okay, so the general rule on an x-axis reflection is that xy goes to x and then -y, so the opposite of y. Think of it that way, as it flips and it goes to the opposite of what it was at in the y, and then it stays the same in the x. Now, one thing that's mentioned here is this figure congruent or similar? And try to remember that congruent means the same exact shape, and similar means that it could be the same shape, but it might be a different size. Okay, so this is congruent and similar because anything that's congruent is also similar because they're exactly the same shape. Okay, it's just moved. So anything really, though, that is congruent is also similar. So that was just kind of a reminder of what those two are, and some of the questions later on will be asking you about that if you choose to do the kind of one type of homework. Okay, so now this same figure, this same ABC, is now going to be reflected over the y-axis. So this axis here, I like to kind of give myself a little line there to be able to see it, but then that's going to be reflected over that axis. So now when I draw the image, I'm going to look across here. So it's A is 1 away here from the y-axis. So now it's going to be 1 away here will be A prime. Okay, and then I'm going to count 1, 2, 3, 4 away here for C, and 1, 2, 3, 4 away here for C prime. Okay, and then 1, 2, 3 away here for B. So 1, 2, 3, B prime will be over here. And now, my husband was kind enough to grab me a ruler. I keep managing to forget to grab a ruler when I start recording. Be a little bit better here. Okay. So there's your image A prime, B prime, C prime. So the original coordinate of A, again, was still that 1, -2. And now you'll notice that A prime is at -1, -2. Okay, B was at 3, 0. And now B prime is back here, and it'll be at -3, 0. And C was at 4, -2 originally. And now C prime will be at -4, -2. Okay, so the general rule for a y-axis reflection will be that the y remains the same as you see, but the x becomes the opposite of what it was. So if it was negative, it's going to become positive. And here these were positive, so they're going to become negative. Okay? All right, so now we're going to do another reflection, just kind of some more practice. If you feel like you're pretty comfortable, I think you can kind of stop watching here if you'd like. So I'm going to draw an original triangle of J, which is 0, 2. I should probably move this. So J, which is 0, 2. K, which is at 3, 4. And L, which is at 5, 1. So here's my original figure. I'll just kind of quickly graph this one. Okay, so there's JKL, and then I'm going to reflect this over the x-axis. So my new figure will be reflected over this axis here. Okay, and I kind of like to outline it that way, so I'm going to reflect it over that. So it was 1 above, now that L prime will be 1 below. K was 1, 2, 3, 4 above, so we're going to go 1, 2, 3, 4 below. And J was 2 above, so now we're going to go 2 below. Okay, and then there's my coordinates J, K, and L prime. Okay, so this is the prime triangle. And these should look congruent, so they should look like the same shape or approximately, depending on how you drew it. So this one was at 5, whoops, sorry. This one's at 5, -1 there. J prime is at 0, -2. And K prime is at 3, -4. Okay? Now, if I wanted to reflect it twice, and here's where we're going to start to do some stuff which is a combination of things. So if I go ahead and reflect now that second one, and generally speaking, when you reflect, when you do any transformations in order, you take the new one. So I have this new one of 0, -2, 3, -4, and 5, -1, and I'll be reflecting that over the y-axis. Now J prime is going to remain the same at 0, -2. L prime was 5 over this way, so now I have to go 5 over this way. And K prime was 3 over this way, so I have to go 1, 2, 3 over this way. Okay, so my new figure will be here. Okay, so there's that new figure. Okay, now this one, all of these are going to be congruent for the same reasons on the previous page. Oops, you can't see that. And a different combination of two reflections that might either move directly from one to the other. If you're going straight from this to this one, you just could really reverse them. So, in other words, over the y first, then the x. And that would actually just do the exact same thing. Okay, so we're going to do a couple more examples, just to make sure kind of everyone's understanding. So kind of one where we're going to do a few examples where we show something that's not over the x or y axis directly, that is over a different line. So in this case, first of all, we're going to draw the original triangle. So we have A is 0, 1, so right here. and B is 3, 4. So right here, and C is 5, 1. Whoops, not C prime and not B prime. There we go. So A, B, and C, ignore those little prime things there. Okay, so A, B, C here, like that. And then this time, we're going to reflect it over slightly different lines. So it says over x equals -1. So it's been a while since we've done those, but those equal pieces where they equal where it's a line, but it's not the y or the x-axis. So remember, the x-axis, that's the line y equals 0, okay? And the y-axis, the line x equals 0. So what we're looking for now is the line x equals -1, it says. So it's actually right here, this dashed line. And I'm making a dashed line just to show that it's what I'm reflecting over, not necessarily part of the problem. So there's x equals -1. Okay, and then I'm going to go ahead and reflect over that line and give a new image. So we notice that A is 1 away here, so I'm going to do A prime is 1 away there. And then C is 1, 2, 3, 4, 5, 6 away. So I'm going to make it 1, 2, 3, 4, 5, 6 away on this side. C prime. And then B is 1, 2, 3, 4 away. So I'm going to do the same. 1, 2, 3, 4 away. Okay, so there's my new figure, which should be the same, just moved over a bit to the other side, reflected over that x equals -1. Okay, and there we go. So that's the same figure, you'll notice, and it's just reflected across over x equals -1. So A prime is -2, 1. B prime in this case is -5, 4. Okay, and C prime is -7, 1. Okay. So, all right, so let's do this other one where it's over y equals -2 in this case. So this one, we're going to draw the original again, and it's the same original. So A is at 0, 1, so we're right here. A and B is at 3, 4, so 3, 4 again. And C is at 5, 1. Okay, keep wanting to make that one prime for some reason. So here we have A, B, and C again. And this time, we're going to reflect over, it says, over y equals -2 here. Okay? So, this time our line that we're reflecting over is y equals -2. So, remember, this is the y equals 0 line, so I'm going to go down 1, 2. So here is y equals -2. Okay? So I'm reflecting it over that line. So now I'm going to notice that it goes up 1, 2, 3. A is 3 above that line right here. So it's going to go 1, 2, 3 below. So here's A prime. Okay, and if I look 1, 2, 3, 4, 5, 6 above is where B is. So I'm going to go 1, 2, 3, 4, 5, 6 below for B prime. And then my last one, this is 1, 2, 3 above is where C is. So 1, 2, 3 below is where C prime will be. And then I will draw my new figure and give the coordinates. Sometimes they look a little bit like they aren't quite fully congruent because of the way you draw the lines. That happens to me a lot because my lines are not always perfect. But as long as they're pretty close, and you can tell they should have been. So in this case, A prime was at 0, -5 here. Okay, and B prime was at 3, -8. And then C prime went down to, it was at 5, but instead in this case, -5. Okay? So that's how you flip over a line where it's y equals. All right, now I'm just going to show a couple more examples, and then we'll be done with the notes, or the kind of, you're probably not actually doing it that way. So, okay, so I'm going to draw the line of reflection really quickly. We're between these two, and then I'm just going to write the equation. So here's my one figure, here's my other figure. So the line of reflection here, and I'm not sure if you're going to be able to see it in this color, is actually the y-axis. So there's the line in the middle there. And what is the equation for that? Well, remember, it's x equals 0. So that was flipped over the y-axis, or the line x equals 0. Okay? And then same thing here is what we're going to do here. Now I want to figure out what's like exactly in the middle here. So if I go 2 down and I go 2 up, you'll notice that's kind of where it got reflected, right in the middle of these two things. So it was 2 above and 2 below. So here's my line right here is where it was reflected across that line. And that line, of course, is down 1 from the x-axis. Remember, the x-axis is y equals 0, so this is y equals -1. Okay, so those are a couple where it shows you like where the line of reflection is. I'm going to do one more problem because this kind of combines a couple of things. Combines like a reflection and a translation, although you won't be doing this yet. You will be doing it soon, so I'm going to show one more problem and then kind of be done. So here's the original one, and the first thing we're going to do is reflect that over the x-axis. So here's the x-axis here, okay, and I'm going to reflect it over that. So that was up 1, so now it's down 1, so f prime. Okay, this is up 2, so now let's make it down 2. Where's e prime? This is up 2 from the x-axis, so c prime is going to be down 2 here. And d 1, 2, 3, 4 up. So it's going to be 1, 2, 3, 4 down for d prime. Okay, it's a little hard to tell that O is the origin. They probably should have just left that out because it's kind of hard to tell that's not a point, but it isn't. So here is that figure. Okay. And then it says now we're going to create one more polygon. So we labeled that all the first prime. And then we're going to create one more polygon that translates this one 3 left and up 2. So we're going to take each of these points. So this is C prime here. So C double prime will go 1, 2, 3 to the left and up 2. So here's C double prime. And then 1, 2, 3 to the left and up 1, 2. So that would be F double prime. Okay, and then E 1, 2, 3 to the left and up 2. So here's E double prime. And moving this one over 1, 2, 3 to the left and up 2. So it actually is exactly where C original or C prime was. And then here's the final thing in the coordinates of C prime. That's at -3, 0. And then I'll just draw my final figure here and be finished. And that's kind of a multi-step transformation where you have 2 different things happen, which you won't have to do immediately, but you will have to kind of show eventually. There you go. And of course it's congruent just like the other figures because nothing's been done that has made the figure larger or smaller or anything like that. We'll do that later. All right. Thanks for listening and have a wonderful day.